Okay, let's dive right in. Have you ever looked at a sales tag or recipe or maybe a news report and seen all these different kinds of numbers? We're talking about fractions, decimals, and percentages. They might seem like they're speaking three different languages, but they're not. Today, we're going to crack the code and show you that they're really all part of the same family.
So, to get us started, here's a classic little puzzle. Take a look at these three numbers. At first glance, it's kind of tough to tell which one's the biggest, right? Is it the fraction, the percentage, or the decimal? This kind of confusion is exactly what we are here to clear up for good. And here's the good news. It is nowhere near as complicated as it looks. There's a secret that connects all of them. So stick with me, and by the end of this short explainer, you'll be able to look right back at this question, and the answer will be totally obvious. All right, so to crack any code, you have to start with the foundation, right? The original blueprint for all these numbers is the fraction. Seriously, if you can really get your head around fractions, everything else just clicks into place. So what even is a fraction? Well, it's just a way of talking about a piece of something. You've got the numerator on top, that's how many parts you actually have, and then there's the denominator on the bottom. That tells you how many equal pieces the whole thing was sliced into in the first place. You can even think of it as a little division problem in disguise. And let's make that real. Imagine you've got 2 pizzas and 5 hungry kids. How are you going to share them equally? I mean, you can't give each kid a whole pizza. The answer is a fraction. Each child gets 2 divided by 5, or 2/5 of a pizza. And just like that, you see how fractions pop up to solve everyday problems. Okay, but here's where it gets really interesting. A fraction isn't just a number sitting there, it can be an action. Think of it like an operator. It's a command, a mathematical instruction telling you to do something, usually to find a piece of a bigger number. So how does that command work? Let's say you want to find 3/4 of 36. It's a simple 2-step mission. First, you just divide the whole amount by the bottom number, the denominator. So 36 divided by 4 gives you 9. That tells you what 1 single quarter is worth. Step 2, multiply that result by the top number, the numerator. So 9 times 3 is 27, and that's it. 3/4 of 36 is 27. Okay, so that's our foundation. Now that we're solid on fractions, it's time to meet the rest of the family. The relatives who often show up in disguise, percentages and decimals. The word percentage literally means per 100. So a percentage is really just a special kind of fraction. It's a fraction where that bottom number, the denominator, is always 100. That is the whole secret. So when you see 75%, it's just a fancy way of saying 75 out of 100. So check this out. On the left, you've got the fraction 3/4. That's 3 parts out of a total of 4. And on the right, you have 75%, which we now know means 75 parts out of 100. They look totally different, but they represent the exact same amount. And what about our third family member, decimals? Well, you probably guessed it, they are also just another type of fraction. They're specifically fractions where the denominator is always a power of 10. Like tenths or hundredths or thousands. That little decimal point is just a clever shortcut so we don't have to write the fraction line. Okay, so if they're all related, how do we get them to speak the same language? This next part is all about the super practical skill of conversion, because once you know how to translate between them, you can compare absolutely anything. The secret word here, the one that unlocks everything, is equivalence. It's a simple, powerful idea. A number can wear different outfits. It can dress up as a fraction, a decimal, or a percentage. But underneath it all, it's the exact same value. So let's see this whole equivalence thing play out in real time. We're going to take one single value and look at its 3 different disguises. First up, here's our starting point, the fraction 7/10. Now here it is, dressed up as a decimal, 0.7. That 7 is in the tenths place. You see the connection, right? And finally, as a percentage, 70%. 7/10, 0.7, and 70%, they are all just different names for the exact same number. But wait, how we do that conversion? Well, to turn a fraction into a percentage, you just have one goal. Make its denominator 100. So for 7/10, we multiply the top and the bottom by 10. That gives us 70 hundredths. And once that bottom number is 100, you're done. The top number is your percentage. It's that easy. All right, we have all the tools we need now. It's time to go back to that original mystery and put our new skills to the test. Let's solve this thing once and for all. Here it is, the golden rule. If you're going to remember one thing from all this, make it this. To compare different forms, you absolutely have to convert them all to the same format. And you know what's usually the easiest? Turning everything into percentages. Let's apply that rule. We take 3/5, do a quick conversion, and boom, that's 60%. 50% is, well, it's already a percentage, so that's easy. And 0.45, that's just 4500ths, so it's 45%. See? Now that they're all lined up as percentages, comparing them is a piece of cake. And there it is, clear as day. 60% is obviously bigger than 50, which is bigger than 45. So our winner, the biggest number of the three, was the fraction all along. 3/5. Mystery solved. And you know what? This is just the beginning. These same ideas of equivalence and conversion work for other types of fractions too, like improper fractions, where the top is bigger than the bottom, or mixed numbers that have a whole number attached. Your new skills have basically unlocked a whole new world of numbers. So I'll leave you with a final thought to take with you. Now that you're a code cracker, a translator between these number languages, where are you going to start spotting them out in the real world? Is it going to be the 25% off sale at your favorite store, the 1/2 cup of sugar in a recipe, or maybe the 0.8 increase in some report? The numbers are everywhere, but now you speak the language.